What's up, Math 6 students? Here we are for the second part of 8.3, finding the area of pyramids. How do I find the surface area of a triangular pyramid? Whew, look at this thing. This is complicated, but I think we're going to be able to handle it. Find the surface area of the triangular pyramid. So the thing about a triangular pyramid is that everything is triangles. So you can see the base here, and it's down below at the bottom. Here's the base, and that's this red space here. Maybe I should have done this in red. But the point is that that base is what we call an equilateral triangle. And they don't mention that here, but it is. It's an equilateral triangle. And that means that the sides of the triangle are all the exact same length. And that's important. The reason it's important is if you're trying to find the area of all the lateral triangle faces, right? The lateral triangular faces are this one, and this one. It's cool if the base is an equilateral triangle because then all three of these lateral triangles will be the same because they'll all have the same base. So in your homework, you're going to have all equilateral triangles. If this triangle had different lengths on the sides, these lateral triangles would all be different, and you'd have to write a bunch of different formulas to find the area of each one. Okay, surface area, SA, that means that you have a three-dimensional solid that you're finding the area of all of the faces, you're adding them together. And we're going to start with the base. Well, the base, if you can see, I'm going to get rid of this red thing here. Remember, we need dimensions that are perpendicular. We're looking for this right angle box. We're looking for this right angle box. That tells us that these sides are perpendicular. That means this side must be perpendicular to this dimension here. Well, this side is 6. 5.2 feet is this perpendicular one, and that 90-degree angle box tells us that. And the reason we need perpendicular dimensions is that, after all, you're finding area, and area is the number of squares it takes. Once again, I'm drawing an amazing square. Squares it takes to find or to cover an entire flat surface. And the sides of a square are perpendicular. So it's the same thing when you're finding the area. So 6 times 5.2 divided by 2. Why are we dividing by 2? Because this is a triangle. And to find the area of a triangle, you have to divide by 2. So that will take care of the area of the base, the red one. But now we have to add to that, because since it's surface area, all of the face areas added together. How many lateral triangles are there this time? 3. And they're all the same because I said this is an equilateral triangle. So that's 3 times, well, where's the perpendicular side on our lateral triangle? Do you see the right angle box right here? There's a right angle box right here. It's a little confusing. It's hard to see, but there's a right angle box there. That means that this bottom is perpendicular to this edge going up to the top vertex. Well, how long is this? Well, if this is 6 and it's an equilateral triangle, this is also 6 feet. And the perpendicular height is 8 feet. So that's base times height divided by 2. Why am I dividing by 2? The lateral triangle, right? A triangle is half the area of a rectangle, so you have to divide by 2. Okay, line down the middle. We have to follow order of operations here. 6 times 5.2. Well, this is kind of weird. I think you can do it though. 6 times 2 is, or 0.2 is 1.2. And then 6 times 5 is 30. So that's 31.2 divided by 2 plus. And then this one, I'm just going to multiply on the inside. 6 times 8 was 48, divided by 2 is 24. That's one way I could do it. I realized, though, because this is multiplication, you couldn't do it if it was addition or subtraction. You could actually cross-cancel here. I could either cross-cancel the 6 or the 8. I'll cross-cancel the 6. 3, 1. Okay? because 2 goes into 2 once, 2 goes into 6 3 times. 3 times 8 is 24. This becomes 3 times 24. Now that I've done that kind of, just in my head, I'm going to get out a calculator and do it again. I'm just going to make sure, verify that I haven't made any mistakes. Otherwise, I type it into big ideas and I possibly get it wrong. 6 times 5.2. Let's make sure I have that right. 6 times 5.2. Woo! I got it right. Okay, and then 6 times 8, and then whatever that product is divided by 2. So I'll clear, and now 6 times 8 equals 48 divided by 2, 24. Woo! Okay, 31.2 divided by 2. I could do that in my head, but since I already have the calculator out, oops, I made a mistake. Clear, 31.2. I already have the calculator out, so I'll just use it. And that equals 15.6. So I'm going to write that down because otherwise I'll forget. So the value of this is 15 and 6/10. The decimal means and, the 6 is in the tenths place, plus 3 times 24. I think I could actually do that without a calculator. 3 times 24 is the same as 3 times 25 minus 3. Because if I go up to 25, I'm adding another group of 3, but then I'll just take it away. 3 times 25, that's like quarters. 3 times 25 is 75, minus the 3 that I added. It should be 72. But I'll just try it here. Clear. 3 times 24 equals 72. And now I can just add the 72 plus the 15 and 6/10. And I should be able to do that in my head too, but 87 and 6/10. I'll actually do it in my head after I've already done it in the calculator. 87 and 6/10. This is surface area, so that's feet squared. Woohoo! Done. That looks beautiful. Okay, actually, I was going to make sure that this is correct. Well, 72 plus 10 is 82, plus 5 more is 87, plus 0.6 is 87.6. Yep, that worked out. That worked out just fine. So I know I have the correct surface area. And what does this mean? What does this mean? It means that if oh, whoa, that was bad. Let me try it again. Come on, Mr. Plunkett, you can do it. Oh, dude, look at that. I know. You guys can get my autograph after the lesson. All right, this is 1 foot by 1 foot. How many of these would it take, and this is really big, but how many of these would it take to cover this whole entire thing? 87.6. The bases, or 87.6 feet squared. This is a foot squared because it's 1 foot by 1 foot, so it's 1 foot squared. By the way, if you ever found the area of that, the area, it's a square, right? So technically it's base times height or just base times height. Base times base, I don't know. 1 foot times 1 foot, that's 1 foot times 1 foot. And just to make sure you remember, 1 times 1 is 1, feet times feet is feet squared. That's why we call this squared, because a square, if you find the area of it, it's 1 foot squared. Okay, anyway, the base of the triangular pyramids in this section are equal, bases of the triangular pyramids in this section are equilateral triangles. This will not always be true. Each side of an equilateral triangle is the same length. You can hear it in the word equilateral. You can see almost the word equal right there, right? And that's why we use that word equilateral. It just means that all of the sides of this base are, in this case, 6 feet. They're all the same. Don't forget that in order to find the area of a triangle, you have to divide the product of the base and the height by 2. Make sure that the base and the height of the triangle are blank when finding the area. Remember, perpendicular, that right angle box, right? You want that right angle box, so perpendicular. All right, everybody. Well, that ends our lesson for today. You're all doing an excellent job. Keep up the wonderful work. I'm very proud of you. See you the next time.